Hello everyone. Today we will look into properties of exponents. We would mostly multiply terms with exponents. Here is an easy question we can solve. Remember your rules with zero exponents. Here's our vocab. We are looking into exponents, so the number on the bottom will be the base and number on the top will be the exponent. Exponent tells us how many times we need to multiply the base by itself. A power is an expression that represents repeated multiplication of the same factor. 81 is a power of 3 because 81 consists of repeated multiplications of 3's. Here's our first example and first rule. Product of powers property. When two like bases are multiplied together, you combine, add the exponents. Here's our bases, A, and then I can combine the bases as I can combine the exponents, add them together, and plus n. Let's see an example in here. This would be like bases, 4 and 4, and this will turn into 4 to the 3 plus 2, which is equal to 4 to the 5th power. That's all. But how does this work? 4 to the 3rd power means 4 times 4 times 4. We still have a multiplication, and then we have two more 4's to multiply together. At the end, we have 1, 2, 3, 4, 5's 4's multiplied together. So we will write 4 to the 5th power for this one. Here's your you try. Here's our second example. Let's say that we have a value 3 to the 4th power times 2 to the 5th power times 3 times 2 to the 2nd power. In order for us to multiply exponents and multiply exponents with expressions with exponents, we would have to find like bases. These are like bases and 2's are like bases. I can only add the exponents within like bases. So 3 to the 4 and another 3, that 3 will have a secret exponent of 1 even though it's not written. So every time we see a value that doesn't have an exponent on top of it, we will always assume that to be 1. So our first exponent turns into base is 3 and add the exponents 4 plus 1 times 2 to the 5 plus 2. Our problem turns into 3 to the 5th power times 2 to the 7th power. I could not add the exponents any further because we do not have like bases. In order for you to add the exponents, you must have the like bases and in multiplication format. Here is your you try. X to the 3rd power times y times x to the 2nd power times y to the 2nd power. Here is our next property, power to a power property. When an exponential expression is raised to another power, you multiply the exponents. So we have a to the m power, with parentheses we are raising to another power. In this case, we would multiply the exponents, so you would write a to the m times nth power. An example, 5 to the 2nd power raised to the 5th power again, we would write 5 to the 2 times 5 which is equal to 5 to the 10th power. Now let's explain why does this work. 5 to the second to the 5th power can be expressed as like this. 5 to the second power, another 5 to the second power, another 5 to the second power, 5 of those. Exponent tells us to multiply the base as many times as the exponent tells it. So in this case, exponent is 5, tells us to multiply the base by itself 5 times. So here's my base multiplied 5 times. Earlier, with our first property, we learned that we could add the exponents if the bases are same. So I can add the exponents when bases are same. I have 2 plus 2 plus 2 plus 2 plus 2, which will turn into 5 to the 10th power. Repetitive addition is multiplication. That's why we multiply 2 and 5 to get 10. Here's your U try. Here's our next example. Let's say that we have an expression with a to the 5th power raised to a new power, and then it's multiplied with something else too. So in this case, we're going to apply order of operations, GEMDAS, and we will take care of the bigger exponents first, the more higher level of exponents, and then we would add the exponents. At first, I have a to the 5th power raised to the 2nd power. We're going to take care of that first. That means a to the 5 to the 5 times 2, and then a to the 2nd power. That's what our problem turns into. Next, we are going to multiply the exponent, a to the 10th power times a to the 2nd power. Now we can add the exponents because we have like bases. I have a to the 10 plus 2, which is equal to a to the 12th power. This will require us to use the two properties in one problem. Here's your U try. X to the 3rd power times x squared to the 2nd power. Here's our last property for today. Power of a product property. To find the power of a product is multiplication. If we have a multiplied expression and there is an exponent to that multiplied expression, the exponent will apply to both of the pieces. So we will write a to the m power times b to the m power. Here's an example. I will apply my exponent onto both terms, both pieces. So I will apply to 5 and x squared. So I will have 5 to the 5th power and then x squared to the 5th power. We are done applying our new property, but it looks like we created another problem for us, which is power to power property. And let's apply that as well. When we see power to a power, we know that we can multiply the exponents. So I can write this as x to the 10th power. We multiplied 2 and 5 together, and we got 10. That was power to a power property. Here's your U try. Be careful with the negative. Apply to exponent to -3 and n. Let's look at a different example. Let's say we have a problem where we see -2y to the 2nd power times negative 2 y to the fourth power. Now the exponent outside of the parenthesis will apply to every term that is inside. So it's going to apply to the y, and it's going to apply to negative 2. Exponent that's outside of the parenthesis will only apply to the term it's touching. It's only touching to y value, therefore only y will be affected by 4. If I rewrite my expression, we would have negative 2 to the second power and y to the second power and a negative 2 times y to the fourth power. As you can see, the 2 that was touching to the exponent applied to each term that was inside of the parenthesis. And the 4 was only touching to y value, and it did not affect the multiplication of negative 2. Now we can try to add the exponents of like terms, and I can see that I have like terms as 2's. I'm going to put a parenthesis here on this one and exponent 1. That way we know that the bases are same and we can add the exponents in multiplication. So we would write negative 2 to the 2 plus 1 is 3. Also y to the 2 plus 4, which is going to be 6. I have negative 2 to the third power times y to the sixth power. Sometimes when our exponent values are small, it makes it look nicer to evaluate them. And we all know that this is negative 2 times negative 2 times negative 2. So I can rewrite this expression as negative 8 y to the sixth power. Here's your u-try. Negative 2x y squared to the third power. Please make sure to apply the exponents to negative 2, the x, and y to the second power. Here's a challenge. What do we get when we double 2 to the 2017th power? I also have a joke for you guys today. What do you call friends what do you call friends who like math? That's pretty much it. If you have any questions, please make sure to bring it to class.